Okay, hello everyone. Good day. Here we are again solving math problems, either for enjoyment or for learning. Okay, for today we will continue our discussion on special inequalities. So this is part 2 of special inequalities. And again, we will consider two problems and we leave a challenge at the end. So our first problem is, for x positive or 0, what is the smallest possible value of f of x, which is equal to 9x squared plus 36x plus 52 all over 12 over x plus 2? Okay, so recall that for any positive real numbers, any two positive real numbers, a over b plus b over a is at least 2. Or we can also say it in another way. We can say that a number, the sum of a number and its reciprocal is at least 2. Okay? So with that, we have from f of x, which is the ratio of these two expression, 9x squared plus 36x plus 52 all over 12 over x plus 2. Okay, so we complete the square in the numerator. We have 9x squared plus 4x plus 4 plus 52, but since we have added 4 inside the parentheses, we compensate by subtracting 36 outside so that we will maintain the value of the numerator. And so this becomes 9 times x plus 2 quantity squared plus 16 over 12 times x plus 2. And when we break it down into two fractions, we have 9 times x plus 2 squared over 12 times x plus 2, and we have 16 over 12 x plus 2. Then this sum of two rational expressions simplifies into 3 times x plus 2 over 4 plus 4 over 3 times x plus 2. Okay, so notice that the form is similar to that result that says that the sum of a over b plus b over a is at least 2. Because x is positive here, so the numerator and the denominator are positive. So this also is is at least 2. Therefore, that is the smallest possible value of x. Therefore, the minimum possible value of the value of f is 2. Okay. So that's it for the first problem. For the second problem, we have if x plus y is equal to 5, what is the smallest possible value of the sum of x to the 4 plus y to the 4? Okay, so we have 625 is equal to 5 to the fourth. But 5 is equal to x plus y, so we replace it with x plus y. And then performing the binomial expansion, we have x to the fourth plus y to the fourth plus 4x cubed y plus 6x squared y squared plus 4x y cubed, from which we obtain x to the fourth plus y to the fourth is equal to 625 minus 4xy times x squared plus y squared minus 6 quantity xy squared. So we are simply rewriting the expression. Okay. Now, this is at least, or this is greater than or equal to 625 minus 2 times 2xy times x squared plus y squared minus 6xy squared. This is still equal. I have not applied yet an inequality, a special inequality. So this is still equal 625. Okay, 625. But the next step will now be greater than or equal to 625 minus the 2xy is now replaced by x squared plus y squared. Then, and then we copy the original x squared plus y squared, and then we rewrite 6x y quantity squared in the form 3 halves 2xy squared. Now, why is this greater than or equal to 625? Because of this, we know that x minus y quantity squared is greater than or equal to 0, and this is equal to x squared plus y squared minus 2xy, okay, greater than or equal to 0, which gives us x squared plus y squared is greater than or equal to 2xy. Therefore, 2xy is less than x squared plus y squared. So that is the reason why this becomes greater than or equal. Okay, so that is the reason why we have this instead of equality. No, we have applied the inequality 2xy is less than or equal to x squared plus y squared. And so we have, so now, and this is equal to 625. So this is now 2 times x squared plus y squared squared minus 3 halves. Now 2xy by the same inequality that we obtained here on the left hand side. So we replace this by x squared plus y squared squared. Okay. And if we add these two, this will now be equal to 625 minus 7 halves x squared plus y squared squared again. Okay, outside. Okay, that's the result when you add 2 and 3 halves. That's 7 halves. Okay, now this is equal to 625 minus 7 halves times x to the fourth plus y to the fourth plus 2x squared y squared. Okay. But again, we rewrite this as 625 minus 7 halves. We separate the x to the fourth plus y to the fourth. And then we rewrite this one as 2 times xy squared. Like that. Okay. So transposing 7 halves x to the fourth, y to the fourth to the left side, we have, so from which we obtain from which we obtain 9 halves, 9 halves x to the fourth plus y to the fourth is greater than or equal to 625 minus 7 times xy quantity squared, which is greater than 625 minus 7 times x plus y squared over 4, and then outside you have another square. Why is that? Okay, we obtain this expression or this new inequality here from, we have x plus y squared is equal to x squared plus y squared plus 2xy. But x squared plus y squared is greater than 2xy, so this is greater than or equal to 4xy. Okay, okay, so that you will follow, or you can follow. This is greater than or equal to 2xy plus 2xy, which is equal to 4xy, from which we obtain xy, or from which we obtain x plus y quantity squared over 4 is greater than xy. Okay, so this is where we apply this inequality, this one here. Which is so this is now equal to that expression is equal to 625 okay, 625 minus 7 over 16 times 5 to the fourth, because x plus y is equal to 5. Since x plus y is equal to 5, which is equal to 625 1 minus 7 over 16, which is equal to 625 9 over 16. Therefore, x to the fourth plus y to the fourth is greater than or equal to 2 over 9 times 625 times 9 over 16. So you are left with the 9 cancels, so we have 625 over 8. Okay, so that's the final answer. So the smallest possible value of x to the fourth plus y to the fourth is 625 over 8. By the way, these two results, the first one and the second one, are verifiable by calculus. When you use maximum and minimum ideas from calculus, you will be able to show that our answers agree with the answers using calculus. Verifiable by calculus. Oops, okay. So that's it for this video, but as I said, we have a challenge for you. Okay, the challenge is evaluate t, which is equal to 1 minus 1 over x minus 1 over x squared plus 1 over x cubed minus 1 over x to the fourth minus 1 over x to the fifth plus 1 over x to the sixth minus 1 over x to the seventh, and so on. Just observe the pattern when x equals 2. The solution to this problem will be given in the next video. But I hope you will challenge yourself and try to solve this problem first. Yourself, no? Try to solve this problem first before going to that next video. So that's it. I hope you enjoyed our discussion, you learned something, and may God bless you.